Hello everybody, welcome to a new video. In this episode I'm going to show you how to optimize objects, how to place objects on a sheet of plywood, for example, to get the optimal material usage. I'm going to use a very nice, a very powerful tool, a program. I'm going to show you in this video what program it is and how to use it, but I'm going to start in Blender. Today I'm going to make a sign that I will glue to the wall behind my CNC so you can see each time you watch my videos. I'm going to start making the text, but before that I want to thank everybody that supports me through my Patreon page. If you want to support me, help me keep on doing what I'm doing, you can find the link to my Patreon page in the description of this video. You will also find the link to the program that I'm using. You can also support them. I am sure you will help them a lot to develop the program further. Now let's get started. Let's create a simple text in Blender, then we will export it, move to that program and optimize the toolpath, go back to Blender, generate the G-code for the CNC, and then we will move on to Universal G-code Sender into the workshop and I will show you how everything came up. I will also show you some tricks and some options that you have to choose different types of optimization. If you want, you can also use scraps, just define them as a curve in Blender or in Inkscape or in whatever program you are familiar with. Define the shape of the scraps that you have and you will be able to use them at maximum. So let's get started. Let's create a new text. I'm going to select add, then text. Here is the text. If I want to edit the letters, the text itself, I have to enter edit mode. I know this is something that I've struggled with, so whenever you want to modify the text, there's nothing in the right panel, but you have to enter edit mode. So let's write the name of the channel, open source, and I'm going to exit edit mode and add a new text just below this one. Let's move it a little bit around and press tab again to enter edit mode, write CNC, press tab to exit edit mode. With tab you are switching between the modes here, object, edit. This is valid when you are working with text. If you are using different types of objects, the menu here will be a little different. Now let's place it a little bit centered. And I want to cut these letters, but I don't want to cut them just as they are. I want to mix them together in order to maximize the efficiency, to minimize the amount of material that I'm using. So how am I going to do that? First I'm going to convert these two texts. So object, convert to mesh, do the same with the second text, and now select them both using shift of course and press Ctrl J to join them in a single object. And now after creating the text, let's press N to open the right side menu and check its dimensions. As you can see, it is huge, it is 5 meters long. I don't want that. I want it to be somewhere around 800 millimeters, so modify the width. And now I will copy the scale from X to Y2, move it again in the origin, press Ctrl A to apply all transforms, and now I have the text with the correct dimensions that I want. As you can see, the 3D cursor, the point where new objects are being created, has moved way to the left. For that I will press Shift S and select cursor toward the origin or press 1. Now the cursor is in the center. That's not really important, but if you want to add more objects, you might find this useful. As you can see, by copying the scale and applying the transforms, the dimensions are now 800 millimeters by 250 millimeters. Of course, there's no dimension on the Z-axis because it's just a flat object. The last thing that I want to do before exporting is go to the object menu, convert to curve. Now I have just the outline of the text, exactly what I want. Go to File menu, Export Curves SVG. Check selection only, so it will only export the object that I want, the text, and I will change the unit to centimeters. You might want to check first before exporting what units you are using. For me, centimeters is what I want. Click on the curves button and now it has been exported. So now let's move on to the interesting part, the one where we are going to define a piece of material and have this letter placed as efficient as possible on that piece of material. For that, you will find in the description of this video a link to the GitHub page where the software that I'm using is. It's called DeepNest. It's a great piece of software because it can optimize randomly shaped pieces. It's much better than any other program that I have tried, which only takes rectangles. This one will take into account, or can take into account, the shapes, the actual shapes that you are milling. It's very efficient for CNC. Also works for laser because it is able to join common lines to make them just one line to avoid useless passes. So let's go to that address. For now, the latest version is 1.4.0, which I've discovered has some bugs, so I'm going to scroll down and use version 1.3.1. This is the one that works as it should. Probably in the near future there will be another version that will work. The 1.4 isn't able to do exactly what I want to take advantage most, to take the shape of the objects into account and to group them as close as possible to minimize material waste. So here from version 1.31, open the assets and I have the Windows version. For the next version you also have other variants for Linux, so if you are on a different operating system, download whatever version you find, the latest version that you find available, try it, and if things don't work exactly as they should, try a previous version. So I'm going to download this file by clicking on it, extract all the folders, and here I have the DeepNest v1.3.1 exe. Double clicking on it, ignoring the Windows warnings, and this is the program, the DeepNest program. Let me show you in just a couple of clicks how to use it. So click on the import button and I will select the wall logo that I have just exported from Blender. As you can see, it also works with the DXF files. Click on open, it will take a little bit of time, and I have all the letters that I want, each as a separate object. I can also see them here. You can double check the dimensions. As I've told you, when exporting from Blender, you might end up with 2 large objects or 2 small objects. Double check the dimensions here in the list. Now I want to define the shape that I'm going to use. The first variant that I'm going to show you is with a square piece of plywood. I'm going to use a piece of plywood, a scrap piece of 8 millimeters. So I've measured the piece of plywood. It's 44.3 centimeters by 35.9 centimeters. In order to add it to the program, I'm going to press this button, the plus button. So the width is 35.9 and the height of 44.3. Of course, I've measured in centimeters. Here are millimeters, so I'm not going to enter any point. Click on the add button, and here you can see in the list that I have a checkbox under the sheet column. This piece is checked. This means that this one is going to be taken into account as a stock, and it will try to place all these letters on this piece of stock. Let's go to the settings. We will take them one by one in a quick manner, and I'm going to explain to you what you need to set up to get the correct results. First, the display units. Of course, I'm using metric. If you are using inches, check the inches. The space between parts is very important because it depends on the tool bit that you are using to make the cutout. If you are using a 6 millimeters end mill, of course it won't fit in a 4 millimeter space, so you would have to enter a 6 millimeters between the pieces. I'm using a 4 millimeter tool bit, so 4 millimeters should be okay. If it generates some overlapping, I'm going to increase the space to 4.5, but in order to avoid multiple cuts, I'm going to leave it to 4 millimeters. I'm going to leave the curve tolerance just as it is. Again, if you have some intricate patterns and you have some problems, try to lower this value, but remember that lowering it will affect the computation time. The next option is part rotations. It will rotate them 90 degrees. One important thing is that when hovering various options here, you can see on the right a very nice animation which explains what everything does. I'm going to use an 8 part rotation, so they will also be rotated at 45 degrees. And for the optimization type, I'm going to select squeeze because I have a CNC and I don't really care about the spaces. You can see the number 3 option. I might end up with some thin pieces, but I will use them for later projects. If you have very intricate parts, such as this snowflake on the screen, you might want to use this rough approximation, but this means that there won't be any pieces inside other pieces. I want that because my letters are pretty simple, so I'm not going to check this. Also, I'm not going to modify anything at CPU cores. Here at the import export group, they depend on the type of SVG that has been exported out of Blender. Every setting here that is default is okay for me. What I want to check, which isn't checked by default, is the export with sheet bound borders and export with space between sheets, also a value here. This will also generate a curve that defines the shape of the stock that I have defined in the list. If you create this file for a laser cutter, of course, where you have objects one next to each other, you don't need to make 2 passes, so you might want to check this button, which will avoid overlapping movements. There are just a few options, but the program is very powerful. If you somehow by mistake mess something up, you have here a button set all to default and you can start over. Now let's go back to the list of objects. I have the sheet checked here as stock, so press the start nest button. And as you can see, it already started optimizing everything. They fit in my small piece of plywood, my small piece of scrap. You need to know that it simply won't stop. You can see here there are new options, new ways of arranging things calculated. If you find a version that you are satisfied with, just click on the stop nest button, and if you find a previous nesting that you find more suitable to what you want, select it. And now I will click on the stop nest button because the laptop also started making a lot of noise. So I'm going to use the last nesting. Go to the export, click on SVG file. I'm going to use logo letters optimized. I tried this of course before making the video. I'm going to override the file. And now we need to move back to Blender to install the Fabex CNC add-on. Maybe there are some of you that haven't used it until now. It's very easy to install. I will show you in just a couple of seconds. And then we will create a new operation, export the G-code. So back to Blender, I'm going to delete the text. I don't need it anymore. Go to File, Import this time. Select Scalable Vector Graphics from here. And select the logo letters optimized. Click on the import button. As you can see, I have the exact layout that the program generated with an additional rectangle, which is the sheet that I have set as the stock. I'm going to rename it in the list so I know what it is all about, and I'm going to move it out of the group, out of the collection. Why do I do that? Because for the milling operation, I'm going to use the collection as base because each letter is an individual object. I don't want to create, how many are they? 18 different operations. I just want one operation with all the letters. So I will leave them in a group, and I'm going to show you how to select the group as base for the operation. But before doing that, I'm going to show you how to install the Fabex CNC. First, go to the link in the description of this video, download the file from there. Then go to Edit, Preferences, go to Get Extensions, click on this little arrow here, click on Install from Disk, and select the file that you have downloaded. I'm not going to do it again. That is all you have to do, and then you will have something similar with my setup. Let's close the Preferences. You will have this CNC tab here, and in the render engine you will have Fabex CNC cam. If you don't have that, make sure you are using the latest stable Blender version. In this situation is 4.3 and the latest Fabex CNC add-on. And now I will switch the render engine to Fabex CNC. Now I'm going to select the group here, the collection, and in the operations tab click on the plus button. Unfortunately, it didn't use my selection from here, so I want to use all the letters. For that I'm going to change the data source. Instead of object, I'm going to select collection of objects. Now click on the collection and select the local letters optimized. In the right side menu here, if you don't have it, you can press N and toggle its visibility. So if it's hidden, just press N on your keyboard and it will show up. In the CNC tab, let's start setting up the operation to mill these letters out of the 8mm thick plywood piece that I have found in the pile of scraps, and I want, as I've told you, I want to make a nice logo for gluing it to the wall behind my CNC. Make sure you have 3 axes as axis count, and the strategy is profile cutout. Leave it as outside. I want to cut on the outside of the objects, of course. Leave everything just as is. Scroll down to the operation area, and for the start depth I'm going to write 8mm. I want it to start cutting at 8mm, and the maximum depth is going to remain just as is object, because as you can see the letters are on the Z0 level, so that's where I want it to end. The next tab is the cutter. I can use a predefined cutter, which is exactly what I'm going to do, an end cylinder of 4mm. If you don't find in the list, you can select the various types of end mills and the diameter of whatever your tool bit is, the number of flutes, which don't matter, but you might want to write them down just so you know what you are doing. Moving on to the next tab, it is feed rate. I'm going to use a movement speed of 3500 millimeters per minute and a spindle speed of 20,000 RPM. This is the feed rate for the X and the Y axis. The feed rate for the Z axis is defined here as a percentage of this speed. If I want to have the exact same speed, so also 3500 for the Z axis, just change this value to 100%. Any movement that is below 30 degrees will be considered a plunge speed, and it will be created with a speed according to this value set here. One important thing that you need to remember whenever using Blender and Fabex CNC is to check this box here, output trailer, and write the M02 command here, so everything will stop after finishing the job. Otherwise the spindle will keep on spinning, you have to manually stop it. It's not a good thing, so remember to write an M02 which ends everything after the job is finished. Because I want a nice finish on the sides, I'm going to change the mill type from climb to conventional. Make sure you have the correct cutter spinning direction, otherwise a conventional cut will be in fact a climb cut and reverse, so my cutter spins clockwise. I will also increase a little bit the safe height to 15mm. That's all that I need to do. Just go back to the right panel and click on the calculate path and export G-code. As you can see, I have some weird errors here. I will click on cancel, and that is because by mistake I've moved the CAM machine, the object that defines the entire machine, inside the object that I want to mill. To solve this, just drag it and move it to the base collection. Now let's click again on the calculate path button, and I have the tool path here. Of course I want to make several passes. I don't want to make just one single pass. The tool bit might break. So how do I do that? Let's move to the operation area, and here I have the layers checkbox. I'm going to change, of course, the layer height from 10mm to 2mm. That should be safe enough for my 4mm tool bit. Let's click on the calculate path button, and as you can see now I have several passes. But there is one thing that I don't like, which is, well, doesn't matter if I like it or not, I won't end up with a correct result. And as you can see, I have a different layout now with a little bit more distance between them. I will delete the first curve, which is the shape of the sheet. I don't want it because I already have one here. Well, it's informative anyway, it doesn't really matter. What you need to know is that if you don't override the same file, the collection will be different, and you need to change it from here, from the operation. You need to select the new collection because it has the same name as the file that you are using. Now let's calculate the toolpath again, and as you can see, everything is okay. All the letters are milled correctly, but there is a problem. I will have these pieces inside the E, inside O, inside P. They will fly away. I don't want that. I want to have some small holding tabs. In Fabex CNC, they are under the operation setup tab, the first tab. You can find them with the name bridges. So I will click on this button. Let's make them 4 millimeters wide with a height of 1 millimeter, and I have to select a collection, or I have this button here which is auto generate. You can see some curves here, some drawings. You will find them in the bridges group. I have all these bridges. Let's calculate the operation with the default auto-generated bridges. Click on the calculate path again, and as you can see, the cutter will be lifted whenever cutting over these small pieces. You can modify them, you can move them around, you can make them larger by entering edit mode. They are simple curves, and whenever you find such a curve, you will have a movement of the cutter head with this height, which will avoid cutting the entire material. It's very useful to avoid having pieces flying around. After making the toolpath, calculating the operation, I still need to export the G-code so I can move to Universal G-code Sender and make the actual milling on my machine. If you haven't saved the Blender file, you will have a difficult time finding the G-code file. So first save the Blender file, and when clicking on the export G-code button, it will be saved in the same folder with the name of the operation. So if you want a nicer file name, you have this option here. So let's write letters for the wall G-code, and if I click the export button, I will find the file under that name. But before moving to the workshop and making the actual milling, I want to show you something, as I've told you in the beginning of the video, something incredibly powerful about DeepNest. And let's go back from the layout. I will have to use a different program for this. I'm using Inkscape. You can also create the shapes in Blender and export them just as we have exported the letters, but I prefer Inkscape. For me it's much easier. And let's say I have a piece of material left from a previous operation which isn't a perfect square or a perfect rectangle. Let's say I have an ellipse. I will draw it here in Inkscape, give it dimensions, so let's say it's 300 millimeters wide by 500 millimeters tall. And I have this ellipse. I'm going to save the file, and I'm going to call it scrap stock. Press save. Now I can close Inkscape. Let's move to DeepNest again, click on import again, and let's import the scrap stock. Click on open. I will delete the stock that we have created at the beginning of this video, and I will check this checkbox here next to the object that I have imported. Now, if I click on the Start Nest button, you will see that everything has been fitted inside this object. I can stop the nest. I will export the file, logo lectures optimized, and I will call it random shaped stock. Press on the save button, and now let's go back to Blender. I will delete everything. I will leave the operation just as is because I will change the collection. Go to File, Import SVG again. So select the logo letters optimized random shape stock, click on import SVG, and as you can see I have the shape of the stock here. This is useful because I want to know how to place it on the CNC table. Now let's move it to the default collection so I can have in this group just the objects that I want to mill. And let's change the collection. As I've said earlier, if you change the file name, the collection name will be different, so I have to select it again, and now I can calculate the toolpath. After modifying this, I don't have the bridges anymore, so I have to go back to this menu and click on the auto generate again. The collection name has been updated. I can click on the calculate path button, and now I have the toolpath for the new layout that fits inside this ellipse shaped stock that I had laying around. Another thing that I like about DeepNest, let's go back to Inkscape and modify that file with the stock again, and I will show you something that I really love about this program. So let's open the file, and let's say that Besides this ellipse stock, I also have a square, another piece. I will save the file again, go back to DeepNest, let's delete the stock, click on import again, scrap stock, and I have these two objects. I can check them both. They will both be taken into account as stock pieces. Let's start the nesting. As you can see now, it used both pieces. Probably if it will keep on optimizing, it will only use one of the pieces. But this is something very important, that you can use various type pieces, each with its own shape, and you can optimize everything for making the most out of the scrap pieces that you have lying around. As you can see, it optimized everything until it only used one piece. And I have something to show you. If I want to make coasters, for example, and I have a lot of pieces that are similar, I don't have to import them 1000 times, 100 times, or whatever, however many times I need. Just go here and let's change the quantity. I want 5 C letters, click on the start nest, and it will place 5 of those objects inside my layout. This time probably it will use both of the sheets. You need to take care to see that all the parts are placed. You can find this information here. Sometimes the stock that you have entered isn't enough and not all the parts will be placed. So make sure you see here all the pieces have been placed. So now let's move on to Universal G-Code Sender. Let's go to the workshop, move on to Universal G-Code Sender and make the actual milling to see how everything turns up in the end.